Hello everyone. So in the previous video, we were looking at the question of how do you find the total output that is required to satisfy a given level of demand by giving the technology matrix. And starting with this particular expression, x is equal to x plus b, we found x by actually using this particular formula. Now, where A denotes your technology matrix and B is the final demand. Let's look at an example and apply this and see how to. Let's see an example of this. Now, okay, so this is a nice big word problem. So each unit of engineering output requires as input 0.2 units of engineering, which means its own product, and 0.4 units of transport. Each unit of transport output requires as input 0.2 units of engineering and 0.1 units of transport. Determine the level of total output that is needed to satisfy a final demand of 760 units of engineering and 420 units of transport. Okay, so let's fill in the final demand vector first because that's fairly straightforward here. So we need 760 units of engineering and 420 units of transport. Now, the rest of the information that's given in the first part of this word problem looks like it's actually helping us figure out the technology matrix. Because for each unit of engineering output, now if we measure output in columns and I have engineering here, for each unit of that, I'm going to need 0.2 units of, to produce that, I want as input 0.2 units of engineering, which means here engineering to engineering will be 0.2. And transport into engineering is now 0.4. And similarly, to produce every unit of transport output, I'm going to need as input 0.2 from engineering and 0.1 from transport. So there we go. So we've actually written down our technology matrix. So if we write x equals ax plus b. Now x is going to be x1 and x2, which will be the outputs of engineering and transport. A is just 0.2, 0.5, and 0.1. B is 760. Now we saw earlier that to find x, we do I minus inverse into B. Now let's compute I minus A inverse. For that, we need I minus A. And I minus A is actually just an identity matrix of the same order as A, because only then you can do the matrix subtraction, right? So we have a 2 by 2 identity matrix minus we have the technology matrix 0.2, 0.2, 0.4, and 0.4. So this now becomes 0.8, this 0.2, this 0.4, and minus 0.1. Now to compute I minus A inverse, we need to check if determinant of I minus A is positive. I mean if it's 0 or non-zero. So let's do determinant of I minus A, and that is 8. So this will be 0.72 minus 0. And that is actually 0.60, which is not see. Therefore, I minus A inverse exists. Just add a page here. So I minus A inverse will now be 1 by determinant of I minus A into adjoint of I minus A. And in the 2 by 2 case, we're going to write the adjoint by actually swapping the diagonal elements. So instead of 0.8 and 0.9, we have 0.9 and 0.8. And the other off diagonal elements will now have negative sign in front of them. So instead of minus 0.2, we have minus of minus 0.2, which becomes plus 0.2. And this becomes plus 0.2. And I minus A inverse is actually just 0.64. So we have 1 by 0.64. We just going to put that. So now to compute x, we need I minus A inverse into B, which will be 1 by 0.64, 0.9, 0.2, 0.4, 0.8 times B, which was 760 and 420. So let's do the product of these two matrices and then we'll divide by 0.64. So we keep 0.64 as it is. So 0.9 into 760. So we're going to have 684. Yeah, this will be 684 plus 0.2 into 420 will be, I think, 84. Then 0.4 into 760 is going to be 304 plus 0.8 into 420 is going to be, I think, 336. So let's see. So this is 0.64. We have 684 plus 84. So there are 8, 768. And 304 plus 336 is now 6. So let's see. 64 times 64 times 10 will be 6.64 into 100 will give us 64. So this will be 1000. So let's see. So 768 by 64 will actually go once. Yeah, this will be 12. So this will be 12. And that is actually your final output vector. We just have one more thing to do, and we'll just have one more question to answer, and I will take that up in the next video. So let me just quickly check if my answers to this problem are right. Yes, they are. So this is 1200 units of output for engineering and 1000 for the transport. So I'll see you in the last and final video of input output analysis. So